Welcome to Study for GATE and ESC solution. In this video, we will discuss the continuation of the fourth video. So here we will start from the question number 19. As shown in figure, this is the figure they have given, and this is the 1 ohm resistance and current flowing through is I. And the overall this is a lumped system. The voltage is given V, and they have given a load equation which is V plus I is equal to 100. And they are telling find the value of this current. So let the solution. This is the problem they have given, and this is the equation they have given. V plus I is equal to 100. This is the circuit they have given. So plus or minus is the voltage V and current flowing I, and the 1 ampere they have given. So according to the Kirchhoff's voltage law, the closed loop is always, sum of the closed will be always 0. So this is V minus plus, so plus V minus, the plus to minus, so minus I plus R is equal to 0. So V minus IR is equal to 0, but R is equal to 1. So V minus I, because R is equal to 0. So this is equation 1. Take this equation 1 and put in equation, take this equation 2 and put in equation 1. So V is equal to I. So in terms of V, we can put I. So I plus I. So V plus I is equal to 100. So V is equal to I. So in this V, we can put I. So I plus I is equal to 100. 2I is equal to 100. So I is equal to 50. 100 by 2 is equal to 50 ampere. So the current flowing through, so the value of the I is equal to 50 ampere. So the current flowing through the 1 ampere resistance I will be the 50 ampere. Question number 20. This is simple one from delta to star and star to delta. And in question number 20, they have given that this is a star connection, this is a delta connection. So this is a delta to star connection. And in this question, they have told that when this is delta connection, they have multiplied by K. Means this delta is multiplied by K. So what's the value we will get in conversion of star? So what's the value we are getting in conversion of star? So option A is given K square, option B is given K, option C is given 1 by K, option D is given root over K. So this is a delta to star connection system. So when we are calculated from delta to star, so normally ABCD are the 4 terminal, and here RA, RB, RC. So when we are calculating conversion from delta to star, the normal formula is product of the adjacent side by sum of the all the sides. Means when we are calculating this one, RA means product of the adjacent, means product of these two by sum of the all the part, sum of the this one, AB, BC and AC. So take this one first, RA, take this RA, this is RA, this is RA, or this one is RA. So this RA. So product of the adjacent means RAB plus RBC, and sum of the all the 3 terminals means RAB plus RBC plus RCC. See it here. AB RA is equal to adjacent RAB plus RAC by RAB plus RAC plus RC, which is the value of RA. Similarly, we can calculate for RBC, product of its adjacent RARB by RAB plus RBC by RAB plus RBC plus RAC, and similarly RAC is equal to RBC plus RAC by RAB plus RBC plus RAC. So in this method we can calculate the next one. In question they have told that delta when each terminal is multiplied by K. So they are asking what's the value of in star connection. So we can calculate first RA. We calculate for RA. So K RAB plus K AC by K. Everywhere is K. So we taken as common K. So RAB plus RBC plus RAC. So here K into K square, RAB into RBC by K, RAB plus RBC. So finally we are getting K. So when in delta connection every element is multiplied by K, then in star also every element multiplied by K. Similarly we can find out for the RB also. So into K into RBC plus K into RAB by everywhere K is multiplied. So taken k into k square, this is k square and this k, so we are getting here k. So we can conclude that when we multiply a k in delta connection star also, we are multiplied the same k value here, k is here. In question number 20, there is a 3 element, this is one element, this is one line, this is one line, 3 element, 3 line A, suppose this stack is A, this is B, this is C. They are asking what is the total power observed by the 3 element. They are asking what's the total power observed by. So in this question we will calculate the observed power and source, means we will calculate here source and a sink. So we at final we will conclude which is the more power. So see the figure. Let's consider this will be the P line, this will be a Q line, this will be the R line, which are less. In P, the current direction is from positive to negative, so it is a plus, this is a minus, so it will be act as sink. Sink means it will absorb power. And in line RC here, the current direction from this direction, so negative to positive, so it will be act as source. In C, in the figure, in line Q, we have to calculate which direction it is. So consider this point as Kirchhoff point O and apply Kirchhoff's law. This is coming, entering here, so take as negative. This is leaving, this is also plus side. So consider this also, we don't know. So is equal to 0. So I is equal to 2 ampere. So this is also leaving because we have got plus 2. So this ampere also leaving here. So in line Q, the current also leaving. So this is also act as source. So we can calculate. So in this figure we have got that line R and Q we have got as source, and line P we can got as sink. So the total power, so we can calculate individual power. So the total sink power is equal to I into P. So here I is equal to 10 ampere, voltage is given 100, so 1000 watt. So we can calculate for source. So line R and line Q, the both are source. So R2, this is the line current flowing to 2 ampere and the voltage will be the 15 volt. So 2 into 15 plus this is the active source also. So 80 into 80. So 2 into 15 30 and 8 into 80 is equal to 64. So the total will be 670 watt. So in this figure we have got that the sink or observed power will be 1000 and the source will be 670 watt. So the total power here, the total observed power is equal to 1000 minus 670 is equal to 330 watt, because here the total observed power is 330 because the total observed power is 1000 and the sink and the source power will be 670. So the more, if you compare these two, the more power will be the source power. So the more power will be sink power. So the total observed sink power is equal to 330 watt. So in question the 21, the option will be 330 watt. So the total observed power will be, they are asking total observed power. So observed power will be 330 watt. In this video we are stopping here. If you like this video, share, like and subscribe. So it is very motivated for to make more and more video. Jai Hind.